Okay, today we're going to cover 15.3 derivatives of logarithmic functions. Basically, in general, this is what we have. When you differentiate ln x with respect to x, what you get is 1 over x, as you can see here. So here, ln x, you differentiate this x, you take the reciprocal of it, you get 1 over x. Okay, just to show you some quick examples now. Example 8. So for example 8 itself, what happens here is you have to use all the other rules that you have learned from the earlier part of your calculus. So now, if I differentiate with respect to x, 1 plus ln x to the power of 0.5, first thing, apply chain rule, you bring down the 0.5, so you get 0.5, 1 plus ln x, 0.5 minus 1 equals to negative 0.5, so I have negative 0.5. Not forgetting that you need to differentiate what's inside the bracket. 1 differentiated gives you 0, ln x differentiated with respect to x gives you 1 over x. So if you were to simplify all of this, you get 1 over 2 square root of 1 plus ln x times 1 over x. You simplify it further, get 2x square root of 1 plus ln x. And that is part A. For part B, similarly, x squared times ln x, if you say that we need to use the product rule, you are correct. So first, if u is x squared, differentiating u with respect to x is 2x. If v is ln x, differentiating v with respect to x is 1 over x. Hence, for part B, differentiating x squared ln x with respect to x will give me v du dx, which is 2x ln x here, times u dv dx. X squared times 1 over x simply gives me x itself. So I get plus x. If you would like to factorize x, what you get is 2 ln x plus 1. Totally optional, but if you like to do so, it's perfectly fine. Okay, now last but not least, for example 8, before I let you all try 8 itself, is part C. Part C, similar. U over v is an application of the quotient rule itself. So if u is x plus 1, du dx is 1. If v is ln x, differentiating v with respect to x is 1 over x. So let's just start to differentiate x plus 1 over ln x with respect to x. So what we get is v times du dx is 1 minus u times dv dx is 1 over x over v squared, so it's ln x squared. Be careful, it's ln x bracket square and it's not the same as ln x square. It's not the same thing, so take note of that. So now, if I want to make everything just slightly simpler for me, I notice that there is a 1 over x here. I multiply everybody by x. So I multiply him by x, multiply him by x to eliminate, and multiply my denominator by x as well. So if I simplify, I get x ln x minus bracket x plus 1 divided by x times ln x squared. Okay, and that's it for my part C. So if part C, for example 8 is done, please attempt try 8, and when you're ready, please unpause the video and I'll give you the answers. Okay, for part A itself is the application of the product rule. So if u is x plus 1, differentiating u with respect to x is 1. If v is ln x, differentiating v with respect to x is 1 over x. Same thing, v du dx plus u dv dx. So that's what we get in this step. Simplification will give me ln x plus 1 plus 1 over x. What they did was they went to expand this term over here. Now, for part B, u over v, So similarly, we apply the quotient rule. So u is equals to ln x. Differentiating u with respect to x is 1 over x. If v is x, differentiating v with respect to x is 1. So v du dx minus u dv dx over v square. I multiply by x to my numerator. Here, actually, x times 1 over x gives you 1 itself, so no need to bother. So the simplified form for b will be over here. Okay, now with example 9. So for example 9, we have this. Okay, what this means is if you have ln u, okay, u being a function itself, what happens if you will take, okay, 1 over u, okay, times du dx. Alright, okay, let me just show you what we can do for this. Okay, so I will basically, what we need to do is to take the reciprocal of it, then you differentiate. It is like when we had ln x, you differentiate, you get 1 over x. You just take the reciprocal of the ln is. So in this case, ln u, you take the reciprocal of 1 over u, then don't forget to differentiate u and put here du dx. Okay, not to worry, let me just, maybe I'll give you an example. It makes better sense to you after this. So from part A, y equals to 5 times ln of 2x squared minus 3. So differentiating y with respect to x, first I write down the 5. Okay, so this 5, we don't touch him. So we start the differentiation here. We take the reciprocal of 2x squared minus 3. So what I have is 1 over 2x squared minus 3. Then we need to differentiate this with respect to x. I get 4x itself. So here I multiply by 4x. So simplification will yield 20x divided by 2x squared minus 3. Now for part B, what we have is y equals to ln 1 minus e to the power of negative x. So differentiating y with respect to x, again, what we do is we take the reciprocal, then we need to differentiate. So if I differentiate this, differentiating 1, u0, here e to the power negative x, you differentiate the negative x, you get minus negative 1. Negative 1 multiplied to this negative 1 gives you positive. So differentiating negative e to the power negative x actually gives me 1. Okay, it gives me positive e to the power of negative x. So if I just put it all together, I get e to the power of negative x divided by 1 minus e to the power of negative x. Okay? So what we have here next is this. Okay, you can just leave it like this. The book actually simplifies it a bit further. If you want me to show you what happens in the book is, they will express e to the power negative x as 1 over e to the power of x. So 1 over e to the power of x multiplied to 1 minus e to the power negative x. So what happens here is e to the power of x times 1 gives you e to the power of x. Then e to the power of x multiplied to this, x plus negative x gives you 0. So I get e to the power of x minus 1. So that's how the simplification occurs for the example in the book. Part C. So in part C, what we have is y equals to ln of 2x minus 1 cubed. So rinse and repeat. Okay, the method here is you take the reciprocal of 2x minus 1 cubed, then you need to start to differentiate 2x minus 1 cubed. So here 3 times 2x minus 1 square. Differentiating 2x gives me 2. Putting it all together, I get 6 times 2x minus 1 square divided by 2x minus 1 cubed. If you simplify, the square here becomes a 1. So what I'm left with is 6 over 2x minus 1. So that is part C. Now for part D, okay, part D maybe is a bit more complicated. So part D, let me just slowly write this out now. So for part D, y is equals to ln x cubed cosine 2x over x plus 1. Wow, this question is okay, never mind. I tell you what, okay, why don't we do this step by step, okay, if not, right, you may get confused. So over here, when we take the reciprocal, it will be x plus 1 over x cubed cosine of 2x. Alright, that's a reciprocal. Then, don't forget we still have to differentiate this data and multiply it out. So, if to differentiate this, notice that there's this, which will enable a product rule. And this over this will be a quotient rule. So, within this question itself, they nestle the product rule and the quotient rule. Okay, don't worry so much about it. So first, I differentiate the x cubed cosine 2x over x plus 1. So differentiating x cubed cosine 2x over x plus 1. So if u is x cubed cosine of 2x, differentiating u with respect to x is v du dx. So cosine 2x, if you differentiate, is negative 2 sine 2x times 3x squared. No, sorry, times x cubed. So, sorry. Okay, du dx, yeah, sorry. So what we have here is we need to apply the product rule itself. So v du dx, so v is cosine 2x times du dx is 3x squared itself. Then plus u, okay, which is x cubed, times dv dx. Cosine 2x will give you negative 2 sine of 2x. So du dx will yield 3x squared cosine of 2x minus 2x cubed sine of 2x. Then what we have here is v is equals to x plus 1, dv dx is equals to 1. So we put it all together down here. So it's v times du dx, which is 3x squared times cosine 2x minus 2x cubed sine 2x, v times du dx minus u, which is x cubed cosine 2x times dv dx, which is here, over v squared. So v squared is simply x plus 1 squared. Alright? Okay, so I've differentiated this x cubed 2x over x plus 1. Okay, this is super messy now, but never mind. Okay, so what we need to do here is this. I think I need to copy out this page. Okay, so what I have here is I need to take the reciprocal, then I multiply by this whole chunk. Okay, so the reciprocal, remember, is x plus 1 x cubed cosine 2x. So I copy out now. So if I'm differentiating dy dx is equals to, first I take the reciprocal, x cubed cosine 2x. Then if you remember earlier, we actually differentiated this already, and this can be found with this huge chunk over here. Okay, just like that. Okay, slowly. Okay, I know there's a huge chunk. First, x plus 1, and this will eliminate. And then here, okay, so we eliminate the x plus 1 first. So if we eliminated the x plus 1, what I have left here is just one more x plus 1, which belongs to this guy, okay, times 3 x squared cosine 2x minus 2x cubed sine 2x minus x cubed cosine 2x over, okay, I limited x plus 1 just now, so I have a x plus 1 x cubed cosine of 2x. Alright, now, okay, let's see if there's anything else that we can actually try to eliminate further. Cosine 2x. So, what happens here is this. Let's try to see if there's something else that we can do down here. Let's see if x plus 1 cosine 2x. Actually, we could be stuck already down here. There is nothing else that we can do over here. Okay, I think I know what we can do. Okay, we can just split it up into different fractions here. So it's x plus 1 over times 3x squared cosine 2x minus x plus 1 times 2x cubed sine 2x minus x cubed cosine of 2x divided by x plus 1 x cubed cosine of 2x. So actually we can split it up into 3 separate fractions. So if I just delete all of this and then I just copy it out, each time. So it's x plus 1 over x cubed cosine 2x, x plus 1 x cubed cosine 2x, and x plus 1 x cubed cosine 2x. So term by term, okay, if you notice for this term, x plus 1 will eliminate each other. Cosine 2x will eliminate each other. So I'm left with these two. So I'm left with 3 over x. Then we can do the next one here. What happens here is x plus 1 eliminates. Sine 2x over cosine 2x will give me tangent 2x. X cubed and x cubed will eliminate. So what I'm left for this term here is 2 times tangent 2x. For the last term over here, cosine 2x eliminates. X cubed and x cubed eliminates. I'm left with 1 over x plus 1. So here will be negative 1 over x plus 1. So if you actually just push everything together, what I get here is this final expression over here. Then I just realized actually that I did something quite silly. Okay, for part D itself, there's actually a simpler way to do this, which I would like to show you now. So for part D, the simpler way will be this. What I can do is to apply the laws of logarithms before I did anything. So if I apply the laws of logarithms, I can actually get ln of x cubed plus ln of cosine 2x minus ln of x plus 1. If I've done this, actually my life becomes a lot easier if I differentiated with respect to x. So first, to differentiate ln of x cubed, I take the reciprocal and I multiply to the differential. Second term, I take the reciprocal, then cosine 2x, you differentiate, you get negative 2 sine of 2x. Negative ln x, you differentiate, you get negative 1 over x plus 0. So in this case, straight away I'll get 3 over x. Okay, here, this term, negative 2 sine 2x over cosine 2x gives you negative 2 tangent 2x, and lastly minus 1 over x. Your life actually becomes exponentially easier. So what I just did just now was actually rocket science. Okay, never mind. Please attempt try 9, and when you're ready, please unpause the video and we will speak about it. Okay, now for try 9 itself, first one, same thing. What you do is you take the reciprocal, okay, then you differentiate. 2x plus 4, you get 2. Hence, you simplify, you get 1 over x plus 2. For part B, you take the reciprocal, differentiating what's inside the bracket, you just get e to the power of x over here. For part C itself, you take the reciprocal, okay, either you can take the reciprocal, or if you do not want, you can actually apply the laws of logarithms first to make your life slightly easier. Then you take the reciprocal, you differentiate, you get a 1. So you get 2 over x plus 1. For the last one, please, okay, don't do it the way that I did. Don't do rocket science. What I can do is to apply the laws of logarithms first. You will get ln of x squared plus ln of sine x minus ln of x plus 1. Once you get to that, you start to do and differentiate each term. You will get this, and this. Simplifying, you should get to these last 2 steps over here. And this is it for try 9 itself. And this is the end, okay, of